Hello, ladies and gentlemen. It's inverse trig time. So here's what we're going to do. We're going to start off just talking about working backwards essentially on the unit circle. If it says that the sine of some angle is radical 3 over 2. So remember, sine is the y values. So we're talking about being somewhere up here. It's got to be positive. So the y values are up here and they're positive. But what's interesting about this is that sine, I'm going to draw a triangle in the first quadrant and I'm going to draw a triangle in the second quadrant and say this y value could be radical 3 over 2 here, or it could be radical 3 over 2 right there. There's two places where this happens on the unit circle. They're in the first and second quadrant. So if I say what are the possible values of theta, I either want this angle or I want this angle. And you should remember that if it's a radical 3 over 2, across from radical 3 over 2, the angle is 60 degrees. So these are 60-degree reference angles. So the angles that theta could be would be 60 degrees in the first quadrant, or in the second quadrant, 180 minus 60, which is 120 degrees. Now, we'll probably be working in radians most of the time, so I'll say theta could be pi over 3 or 2 pi over 3. But what we're doing now is we're kind of trying to figure out where does, whoa, that's not what I meant to do. Where does this happen? So let me get that out of the way. And it happens in two different places, which is kind of an issue that we're going to have to address. So let's talk about one more type of problem like this. It says cosine is radical 2 over 2. The cosine of theta is radical 2 over 2. Remember, cosine is positive on the right side on quadrants 1 and 4. So if I draw a triangle in the first quadrant and I draw a triangle in the fourth quadrant, and I can kind of connect these even. If cosine is radical 2 over 2, that's the x right here. And you should remember that, if it's radical 2 over 2, this is an isosceles triangle. So this is radical 2 over 2, and this is radical 2 over 2. It's negative in the fourth quadrant. This is a 45, 45, 90. So this is 45 degrees, and this is 45 degrees. So I'm going to say theta is either 45 degrees, or you could say negative 45 degrees. And in radians, that would be pi over 4 or negative pi over 4. You could also say 7 pi over 4. That's the same as 8 pi over 4. My head's in the way. Okay, now let's talk about how we're going to address the fact that there's two answers. Because in math class, we don't like having two different answers. We like having one answer. So what we're going to do is, if I ask you to find the inverse sine or the inverse tangent, your answers will always come from quadrants 1 and 4. And let me talk about how that helps us. If I ask you where is sine, like what is the inverse sine of something, your answer will always come from quadrant 1 and 4. And the reason that we chose these is because in quadrant 1, sine is positive, and in quadrant 4, sine is negative. There is no overlap. There's only one place where sine is positive, it's in quadrant 1. There's only one place where sine is negative, and it's in quadrant 4. We are just essentially deciding that this is where your answer will come from. If it's an inverse sine or an inverse tangent problem, your answer will always come from the right side. But there's another trick to this, and that is we're not going to say 7 pi over 4. We're going to say it's going to be between negative 90 and 90 degrees. Like we're not going to say all the way around here. It's either positive 90 or negative 90, and that's the range of answers, which is negative pi over 2 to positive pi over 2. So when I actually do one, I think you'll see what I mean. But if it's an inverse sine or an inverse tangent problem, what I'm telling you is that your answer always comes from the right side and is always between, in degrees, negative 90 and positive 90, or negative pi over 2 and positive pi over 2. And we're going to do the same thing with inverse cosine. We have to decide where is our answer going to come from. So what we do here is we choose from quadrants 1 and 2. Here, x is positive. Here, x is negative. There's no choice. If it's positive, it's coming from the first quadrant. If it's negative, it's coming from the second quadrant. So that's between 0 and 180, which in radians is between 0 and pi. Let me actually work one through, and maybe you kind of make the connection to what I'm trying to say here. It says, find the inverse sine of negative radical 3 over 2. So I'm going to try and sketch this and say, okay, inverse sine. What I said before is if it's an inverse sine problem, your answer has to come from the right side. So I'm just going to kind of say, look, it's over here somewhere. And since sine is negative, it has to be in the, fourth quadrant, because sine is positive in the first quadrant. Oh, that's too bad. So now let's say the sine, this is negative radical 3 over 2, and then you got to remember, okay, this is one of my special rights. That's the 60-degree reference angle. Across from 60 is radical 3 over 2. So in degrees, you can't say 300 degrees. You can't go the long way because your answer has to be between negative 90 and positive 90. So this will say negative 60 degrees, which is negative pi over 3 radians. So the same thing here. Cosine of the inverse cosine of negative 1/2. So back here we said inverse cosine has to be in the top, so my answer has to come from up here somewhere. And if cosine is negative, that means we're in the second quadrant, so it's going to look something like this. Cosine is 1/2, and it's negative in the second quadrant. Let's see, what's across from it? This would be 30 degrees, because across from 1/2 is 30 degrees. So that means this is 60 degrees. And then I'm going to now say my angle. If my reference angle is 60, then my angle that I'm actually working with is 120 degrees, which is 2 pi over 3. So you just have to pick the right quadrant for your answer to come from, and then make sure you know what your answer has to look like. Okay? If you type these in your calculator, these are the only answers you will get, and we're trying to make sure that we understand where they're coming from. Let's do another one. Inverse tangent. So we said before, inverse tangent is going to follow sine in that it's always going to be on the right side. And you hopefully can just remember this, but tangent's positive in the first quadrant. And we've talked about this before, but I'm going to say it again. The tangent of a 60-degree angle is radical 3, and the tangent of a 30-degree angle is radical 3 over 3. It's going to be much easier for you to just have those memorized than it is to try and draw a triangle and then copy, change, flip every time, especially when you're working backwards. So when I see this, if I see radical 3 over 3, I know that this is a 30-degree reference angle. This is either 30 or, in radians, pi over 6. Cool. Let's do a few more. Let's see. I'm going to make some grids here. Okay. Just copy this so I don't need to keep doing it. All right. So cosine, we know that inverse cosine has to come from the top. And if the cosine is negative, then we are somewhere over here. If the cosine is x, negative radical 3 over 2, that means this is 60 degrees, so the reference angle is 30. Then we're saying, all right, that's 180 minus 30, which is 150 degrees, and that's 5 pi over 6. If you don't remember your unit circle, you better hit the unit circle. Inverse sine has to come from the right side, so let's see, inverse sine is negative 1. Negative 1 is, this only happens one spot, it's right there, that's 0, negative 1. When is sine negative 1? Sine is negative 1 down there. And you got to remember, you can't say 270. You have to say negative 90, which is negative pi over 2. Last one, cosine, inverse cosine of 0. So where is cosine 0? Where is the x coordinate 0? Right there. So that's 90 degrees because this is 0, 1, which is pi over 2 radians. All right, so that's inverse functions. Now we're going to kind of combine that and do like two-step problems where you have to evaluate something and then you have to evaluate something else. So first, let's talk about the sine of pi over 2. Pi over 2 is right here at 0, 1. So this is saying what is the inverse sine of, and then the sine of pi over 2 is 1. So what's the inverse sine of 1? That's like saying where is sine 1? Sine is 1 right there. That's at pi over 2 radians, or 90 degrees. Oh, these are inverses. They cancel each other out. The inverse sine of the sine of something is just going to be the argument, the something. So if this is the inverse sine of the sine of 1/2, it's going to be 1/2. Okay, kind of cool. Now, what if we mix this up a little bit? So the cosine of pi over 6, let's see, pi over 6 is, let me do better. Pi over 6 is in the first quadrant, okay? So the cosine of pi over 6, let's see, this is pi over 6, that's 30 degrees, this is 1/2, this is radical 3 over 2, and I want the cosine, so I want the x. So this is 2 times the cosine of pi over 6, 2 times radical 3 over 2. So I want the inverse tangent of 2 times radical 3 over 2 is just radical 3. So the inverse tangent of radical 3, remember, the tangent of 60 is radical 3. So then this is 60 degrees, but if they're using radians, we're going to say pi over 3. So the inverse tangent of 2 times cosine pi over 6 is the same as the inverse tangent of radical 3, which is like saying, where is tangent radical 3? Tangent is radical 3 at pi over 3. So a few more. All right, this one's a little bit trickier, huh? Okay. This says the inverse sine of 1/2. So where is sine 1/2? Let's think, if it's an inverse sine problem, it's got to come from the right side. Sine is the y value, so where is the sine, the y value, 1/2? That's at 30 degrees. Okay, if they don't give me degrees or radians, doesn't matter, I'll just do it in degrees. So this is saying the inverse sine of 1/2, the inverse sine of 1/2 is the angle, so 30 degrees. I want to know what is the tangent of 30 degrees, and we talked about that back here. Tangent of 30 is radical 3 over 3, so this is radical 3 over 3. Ooh, the inverse tangent of 5. Where is tangent 5? Maybe we should draw like a helper triangle for this one, because having tangent be 5 is going to be kind of weird. So let's draw a triangle where tangent is 5. So tangent's positive in the first quadrant. If this is my angle theta, opposite over adjacent would be 5 over 1. So we do Pythagorean theorem. 5 squared, 25, plus 1 squared, 1. 25 plus 1 is 26. That means this is radical 26. So now, I want the cosine of that angle. The cosine of that angle will be 1 over radical 26, which when you rationalize will be radical 26 over 26. That's pretty funky. That's a weird answer. But let me show you, if you bring up the calculator, what happens. See if I know what we're talking about. So I'm going to say the cosine of the inverse tangent of 5. Make sure I'm in degrees, doesn't really matter. Radical 26 over 26. Look at that, huh? That's pretty cool. Okay, so I know I did it right. Calculator doesn't help you a ton because that's not an exact answer. I need an exact answer, but it does help you check it. Let's do one more like that. The cotangent of the inverse sine of 2/3. So since that's not on the unit circle, 2/3 isn't on the unit circle, I'm going to draw a helper triangle. I'm going to say, okay, the sine of some angle is 2/3. 2/3. So now what I need to find is the missing side. So this would be x squared plus 2 squared is 3 squared. Doing Pythagorean theorem, 9 minus 4 is 5. So this is radical 5. And we want the cotangent, so the cotangent is adjacent over opposite, so this would be radical 5 over 2. Just because I can, I'm going to check that one as well to make sure. The cotangent is 1 divided by the tangent, and then I'll say the inverse sine of 2/3. Come on, radical 5 over 2. Radical 5 over 2. Let's go. So we know we're doing it right. Okay, you can check these, but you can't really rely on the calculator. So that's it for your inverse trig. Make sure you try the practice problems and you get your unit circle quiz done. And also hit that like and subscribe button.